You do not need a math degree to understand machine learning. Here's the lie that keeps people out, that before you're allowed to touch a neural network, you have to grind through 4 semesters of university-level math. Real analysis, measure theory, proofs. That's wrong, and worse, it's expensive. It makes smart, capable people quit before they even start. I went and I figured out the actual short list. Not math for math magicians, math for someone who wants to run models, read the papers, and finally understand why this stuff works, without going back to school. It comes down to 3 topics in a very specific priority order. Most of it is conceptual. You'll watch ideas, not memorize formulas. Let me show you exactly what to learn, what to skip, and the fastest path through it. If that sounds useful, hit subscribe. This channel is me learning this stuff out loud in public. Let's fucking go. First, the reframe that makes everything else click. There are 2 completely different skills people lump together as ML math, and confusing them is why folks overstudy and burn out. Skill 1, operating. Running models locally, retrieval augmented generation, hosting, quantization, A/B testing prompts, being the person who makes the thing work. Here's the secret. Operating needs almost no advanced math. If you can handle basic stats, averages, a sense of distributions, you already have enough to operate. Full stop. Skill 2, understanding. Knowing why training works, reading a paper or model card without bouncing off the notation. That's where a little real math pays for itself. This video is about the second skill, and even there, the slice you need is small and mostly conceptual. So if you've been putting off building things because you don't know the math yet, stop waiting. You can operate today and pick up the understanding on the side. 3 topics, ranked by return on investment. Number 1 is the one almost everyone skips, and it's the keystone. Priority 1, linear algebra. This is the literal language machine learning is written in. If you learn only one thing from this video, please learn this. It clears something like 70% of the confusion on its own. And I mean the conceptual version. You are never going to invert a matrix by hand. You don't need proofs, you need a feel for a handful of objects. Start with the vector. Forget the textbook definition. A vector is just a list of numbers, and you can picture it as an arrow in space or a point. That's it. Why care? Because in modern AI, everything becomes a vector. A word, an image, a sentence, all turned into a list of numbers, a point in space. King and queen end up near each other. That's an embedding. Once you see words as points in space, half the magic of language models stops being magic. Next idea, the dot product. 2 vectors, 1 number out, and that number tells you how aligned they are. Pointing the same way, big number. Perpendicular, 0. Hold on to that because attention, the T, and the mechanism inside every transformer is at its heart a giant pile of dot products measuring how relevant is this word to that word. You don't need the full equation today. You need attention is similarity, and similarity is a dot product. Then the matrix. Don't think of it as a spreadsheet. Think of it as an action. A matrix takes space and transforms it, rotates it, stretches it, squishes it. Multiplying by a matrix is applying that transformation. And the single most practical thing on this entire list, tensor shapes. A tensor is just a multidimensional array of numbers, the data flowing through your model, and 90% of the errors you'll hit, especially early, are shape mismatches. You tried to multiply a thing that's 4 by 3 by another thing that's 4 by 3, and it won't go. Once you have an intuition for shapes, what dimensions mean, when 2 things are allowed to multiply, those terrifying red arrow walls turn into, oh, I just need to transpose that. That's intuition alone is worth the price of admission. So for linear algebra, vectors, dot products, matrices, and transformations, and shapes. Skip the hand computation. This one topic is the keystone. Get it, and everything downstream gets easy. Priority 2, probability and statistics. And this one is sneaky valuable because it pays off on both sides, the data going in and the model's behavior coming out. On the data side, it's gentle. Averages, spread, distributions, correlation. If you've ever looked at a column of numbers and asked, what's typical and how spread out is it? You're already doing this. The richer payoff is understanding what the model is actually doing when it makes a decision. Let me give you the one that every person running a language model should know. A model doesn't naturally output probabilities. It spits out raw scores called logits. Just numbers. Could be anything. Softmax is the function that squishes those raw scores into clean probabilities that add up to 100%. That's how the model's gut feeling becomes 73% this word, 19% that word. And here's the knob you've actually touched. Temperature. Ever set temperature to 0.7 and wondered what it does? It reshapes that probability distribution before the model picks. Low temperature, spiky, confident, repetitive, safe. High temperature, flat, surprising, creative, occasionally unhinged. Same with the top piece sampling. It trims the long tail off unlikely options. Once you understand softmax and sampling, those settings stop being magic sliders you nudge and pray over. You know what you're trading. Last piece here, loss. Loss is just a number that measures how wrong the model is. Training is the process of making that number go down. And concepts like overfitting, memorizing the training data instead of learning the pattern are statistical ideas too. You don't need heavy probability theory. You need distributions, softmax, sampling, loss, overfitting. That's the working set. Priority 3, calculus. And I have great news. You just need one idea. Not a course, one idea, and you can get it in a weekend. That idea is the gradient. And the whole intuition is this. A gradient tells you which way is downhill. Picture the model's error, the loss as a landscape with hills and valleys. Training is just walking downhill on that landscape, one step at a time, trying to reach the lowest point, the place where the model is least wrong. The gradient is the arrow pointing in the steepest downhill direction. Take a step that way. Recompute. Step again. That's it. That's training. It has a fancy name, gradient descent, but it's literally rolling a ball downhill. And the learning rate, that's just your step size. Too big, you leap clean over the valley and bounce around forever. Too small, you crawl and training takes ages. Now you know what the hyperparameter actually controls. But Aaron, don't I have to compute gradients? No. This is the best part. A tool like PyTorch has AutoGrad, automatic differentiation. The computer does all the actual derivative calculus for you, perfectly every time. That's the entire point of the framework. So your job is not to differentiate by hand. Your job is to understand the picture. Downhill on the loss, step size matters, the machine does the rest. One idea, conceptual, done. Quick detour, and this one's personal. If you took discrete math, the stuff in a book like Susanna Epps, you are not starting from zero. You already own pieces of the machine. Let me connect them. Functions in Chapter 7. A function is just a rule. F takes an X, gives you a Y. Here's that punchline. A neural network is literally that, one big function. And stacking layers? That's a function composition. F of g of x, the exact notation from your book. You already have the right mental model. Graphs and trees in Chapter 10. And this is everywhere in modern AI. Attention is a graph. Every word a node, every relationship an edge. Backpropagation walks a computational graph backwards. RAG, retrieval, is nearest neighbor search through a space of points. You studied the structure, AI just runs this at scale. Counting and probability, Chapter 9. Combinations and conditional probability, P of A given B, Bayes, That's not adjacent to machine learning math. That is priority 2. You've already met it. In Big O, Chapter 11, this is why you'll hear the detention is O of n squared. Why doubling the context window quadruples the cost. When people complain about long context being expensive, you'll know exactly why from the efficiency chapter you already did. So before you feel behind, open that old textbook. Functions, graphs, probability, Big O notation. You did the groundwork years ago. We're just pointing it at a new target. Now the most freeing part of this whole video. Here's what you can skip, and I mean actively give yourself permission to ignore if you're a builder and an operator. Real analysis, measure theory, most of multivariable calculus, anything proof heavy. This is not easy math versus hard math. It's researcher tooling. If your goal is to invent brand new architecture and publish, you'll eventually want it. If your goal is to build things, run models, and read papers with understanding, it's a detour. Skipping it isn't cutting corners, it's aiming at the right target. And remember, the discrete math we just walked through is the opposite of this list. Keep that, it's working for you. Okay, topics are nice, but the path matters more than the list. Because here's how most people fail. They open a 600-page textbook at chapter 1 and quit by chapter 3. Don't do that. Do this instead. Step 1. Get the intuition, visually first. The gold standard here is 3 blue, 1 brown, Grant Sanderson's animated series. Watch Essence of Linear Algebra, then Essence of Calculus. It's free, it's beautiful, and it moves the needle more than a whole semester of college. This is where you build the feel for vectors and gradients we just talked about. I've linked both series right here. Go watch them. They're the real foundation. Step 2. Learn on demand. Don't try to front load everything. When you hit a real shape error where a paper drops a term that you just don't know, go learn that one thing right then. Just in time applied, and it actually sticks because you needed it. Step 3. For the stats and the softmax and sampling stuff, go to StatQuest. Josh Starmer breaks probability and neural net concepts into tiny, friendly pieces. Perfect for distributions, softmaxed, cross-entropy, all of priority 2, linked here. Step 4. Optional but incredible. Build a tiny neural network from scratch with Andrej Karpathy. His Neural Networks Zero to Hero series starts by building Micrograd, a baby autograd engine, and you literally watch backpropagation and the gradient happen in code. Everything in this video becomes concrete. When you're ready to level up, that's the one linked here. That's the path. Intuition first, lean on demand, stats from StatQuest, then build it yourself. No textbook death march. So that's it. 3 topics: linear algebra for the language and the shapes, probability and statistics for the data and the model's behavior, and 1 idea from calculus, the gradient, walking downhill. Skip the proof-heavy research or math. Go intuition first. The goal was never to turn you into a math magician. It's to take you from "it works and I don't know why" to "I know exactly why." That's an upgrade you can absolutely give yourself, and you can start today. If this made the mountain look climbable, hit the subscribe button. I'm working through this whole stack in public, and the next videos go hands-on. All the resources are linked in the description, and I'll see you in the next one.